Hello, hello. Starting a little bit late tonight, so we don't have to wait for the timer to run out. Let me move my head over. There we go. How is everyone tonight? Hope you guys are doing well. Adjust my seating position. So yesterday was Mother's Day in the U.S. I don't know if it is anywhere else in the world, but here in the U.S. we celebrate our moms at least once a year, hopefully more often than that. And so I thought it would be useful to get into a little bit about how our moms are sort of responsible for a lot of what makes us us. And I thought that we would find that kind of useful, given the time of year, of course, but also because we talk about the brain quite a lot, and there's a lot of brain things here. So we will probably just get rid of this off to the side, turn off the timer. There we go. So tonight I'm going to do a little bit of discussion as usual, but the live stream is called Neurofeedback and Chill because guess what we do? We neurofeedback and we chill. So I'm here to answer questions and hang out about anything you want. Hopefully, neuroscience or neurofeedback related, just because I can often do those topics the most justice. But feel free to ask me anything you like. And I'm going to start off by doing some neurofeedback on myself. And then we will launch into the topic of the evening, which is how your mother shaped your brain, mom's influence on your brain. And we'll talk about some inheritance things. We'll talk about some acquired things. And we'll talk about some of the factors that you might not know about the X chromosome. So let me set myself up with a neurofeedback session. So the first thing I'm going to do is turn off the show title. I see a couple of folks are trickling in. Feel free to say hello, everyone. Let me know if the audio is working. I am plagued with audio trouble. I think it's working, but someone's going to have to confirm. So let me go set up a neurofeedback session. So I'm going to go into my software here and check the frequencies that are set up. It's sort of under my head a little bit. So let me move my head so you can see what I'm doing here. I'll put myself down here at the bottom for a minute. So these are individual, these green things that are above my head are these filters. So you can see the one here is 4 to 7 hertz, and that's measuring theta brainwaves. This piece of software is called Bioexplorer. I usually use something called Eager. So if you want to see the clinical software I use, you can go back at any video with a more blue look to it, a dark blue look to it, and you'll see Eager running. But tonight we're going to use Bioexplorer and keep it pretty old school. A couple of friends of mine who've been using Bioexplorer for years reached out recently, and I wanted to show them a little refresh as well. So 4 to 7 here as a filter is going to measure theta. You can see that I'm sending this out to a box called my low inhibit threshold, and I'm setting that to a MIDI object to create some audio. And then I'm doing something similar with a high frequency inhibit, 22 to 34, and then this is a low frequency beta, 11.75 to 14.75. And so all of these are being thresholded or measuring their averages moment to moment, and then depending on if they're going up or down, I'm going to allow the signal to pass through. And then I'm going to add all those thresholds together. So if my theta and my fast beta are below a certain level, and my medium beta is above a certain level, all at the same time, that's an AND object, then I'm going to increment a counter. I'm going to show that on the points, and I'm going to trigger the audio. Actually, in this case, I'm triggering the audio when all 3 conditions are met. So I'm enabling sounds based on different frequencies, and I'm changing some of the notes and some of the length of sounds based on what's happening in my brain, or I will be in a moment. And so there's nothing on the screen right now because I have to put some things in my head, but let me first set the amplifier up. It says no port, so let me make sure I can find my amplifier. It says COM5. There it is. Apply. Okay, now it says connected. You can see here in the upper right. It says PNWiz on COM5, connected. And you can see we have 4 channels showing up because I'm using a 4-channel UWIS tonight. And this is set up for 12 minutes. I think I'm going to do a little bit longer tonight just so I can talk to you guys a little longer. So let me set this up for, I don't know, let's do 18 minutes. That's a good single session, good long single session. 16, 17, 18. Okay, cool. All right, so let me put some wires on my head while I'm saying hello to anyone who wants to say hello and answer any initial questions. And then once I start the training session, I'll explain that a little bit and then launch into the topic. Hey, Radar Ashwood, how are you tonight? Let me know if my audio is sufficient, would you? I'm guessing it's okay. Put myself back up here on top. Okay. Time for the wire phase. So hope you guys are doing well. What'd you do for your mother on Mother's Day? Anything good? It's okay if you didn't. I won't tell her. She probably knows. All right, so we have ear clips. I'm going to pull out a couple of those. There we go. So there's one. I'll put that on my head. Got a little bit of electrolyte paste here that's running kind of low, this tacky 1020 paste. This is used for wires that don't have any curvature to them. You can kind of get a good sticky on just from the paste itself. And so I'm using an ear clip here, and I've covered the interior surfaces of a silver electrode hanging off my head. Got a left ear. And let me plug this in. I think we're going to do a montage tonight of, let's do C4 minus A1. So on these amplifiers, to make one channel of data, you do red minus black, and then plug in a ground into the green. And the ground can go anywhere you want. So red minus black, the minus is the reference. So that's the left ear. I'm going to take another clip and paste it up. Thanks, Radar, for the audio confirmation. Appreciate it. And I'm going to paste this one up. Hanging off my head. And this is the ground. You can put them anywhere you want because they're not really measured. They're kind of a reference point for the signal. So I'm just going to plug this into the green socket, and then before my cats come and try to take them away, I'm going to hide the rest of the wires that I have because I have too many. I have one here I'm going to wear, and then I'm going to take the rest and put them out of cat's reach. Because if I don't, we're going to be rudely interrupted by a couple of cats who think it's their turn for a live stream. All right, so there's 2. I apparently have too many wires out. Let's get that one out too. Okay, so I have one more wire to put on, which is right here. And this one's going to the red socket because it's the active, if you will. When you say active minus reference on a bipolar montage, it's kind of meaningless because you could flip them and all it would do is turn the waveform upside down. So they're both kind of active, if you will. They're being subtracted to create the signal. So let's paste up the third wire. I'm going to do it as a C4, so a right-hand side of my head. This is over a part of the brain involved with executive function and sleep and a bunch of other stuff. Radar saying, just got stuff for crafts. You got your mom stuff for crafts? That's cool. Is like card making. You're going to crafty mom? That's nice. Oh, why haven't been a NeuroNoodle? I've been working on so many projects recently that I haven't had time to do another sort of live stream. I thought that, I needed just the time for other stuff. But as I have more time for YouTube, I thought it made more sense to produce more short form videos because I think those might hit harder and go further than a live stream does. So part of my decision was to not spend every week on NeuroNoodle was because I can spend some of that time doing other production. And right now that's a lot of programming, but the reason I carved the time out was to take time for more video production. So I promise I'll get you some videos produced. This topic tonight, in fact, I usually write a little article that dives deeply into the topic for you of the live stream. And I sort of wrote one. I got pretty far through a bunch of summary topics and some literature citations for each of the things that I'm going to talk about tonight, but it's just not complete enough for this topic. And so I want to hear any questions you have about this topic as I walk through the 5 things that your mom might have done, or that your mom, her genes, her brain, her stress, may have influenced you. So I'm going to go through those 5 things. And as I do, please let me know as you have questions. Let me make sure the session's running first and explain the neurofeedback session. All right, so I'm going to start this session, hit play, which is behind my head. You can see some squiggles there. I'm not going to bother moving my head over, I don't think. Maybe a little bit. Can I resize this? Let's see. No, I guess I can resize it. I can't make it narrower. So let me turn the audio up for a second. Okay. So what's happening is I am doing some real-time brain training right now, and the audio is really quiet. Let me turn that up a little bit further. Okay. So let me know. You may not be able to hear the audio coming off the computer right now, but it's kind of dinging and chiming as we go. And the reason it's doing that is because I've set these thresholds up. I'm watching the amount of brain waves that I'm making in 3 different brain waves. You can see them there on the screen below me. The one on the far left, which is a mostly red bar, keeps going from red to gray, is the slow brain wave, the 4 to 7 inhibit. So what I'm doing is measuring the amount of 4 to 7 brain waves I'm making moment to moment. And you can see a little green crossbar. And whenever my brain is making theta that's below a certain level, it's going to allow the audio to happen. And the green bar is my beta brain waves. I want to make more of that. So I've set this one up to only allow the signal or the audio to happen when it's increasing or going up. And so you can see the green bar only goes green when it's above its threshold. So I put a visual cue into the design here so you can glance at it and tell if things are in range. And the yellow is my high frequency beta. So when my beta is below a certain level, then it's allowing, again, the audio to happen. And there's a few other things you may have noticed if you're savvy with BioExplorer, that I'm tying things like a volume swell and the length of the note into a few parameters. And so that'll create a little bit of an interesting signal for my brain to hear as well. So you're hearing little random pitches, but also volume swells and length swells. And then below, just to complete the explanation of what I've built here for an audio training design, the little scrolling thing in the bottom is a frequency plot over time. So you can see that my slow frequencies on the left have a lot higher amplitude than the faster frequencies, which is the same thing you're seeing in the more instantaneous frequency plot of the bars jumping up and down. You know, this slope that goes down, I guess it's this way on the screen, is suggesting that slower brain waves, thetas and deltas, are high amplitude. Green there on this bottom right plot. And then you saw there a little surge of blue that just came up, of dark blue. That's alpha waves. And so if I close my eyes, you'll see a surge of blue, the little blue spike in the middle of that plot. And you'll also should see it kind of showing up in the trace that's scrolling. So let me close my eyes for a few seconds and shut off my visual cortex. And we can see if my alpha capture is being picked up. All right, eyes are closed. Yeah, so there's my alpha, the little red stripe, there's the alpha, and the blue is high. I caught for a second. And I opened my eyes up again, so now we're losing the cohesion on that red stripe at 10 hertz, showing my alpha. So this is a pretty basic design, but I really like it for training the brain because it's pretty low key and you can just kind of do other stuff like work on projects when you're training the brain. So if you want to learn how to make BioExplorer designs, if you want to learn how to train your own brain, this is something that I do, is teach you how to go after making changes, usually with acute EEG or a brain map first, and then we build tailored protocols to help you change your brain. And my company, Peak Brain, offers that at a discount for any listener of this podcast or this live stream, so feel free. So let me talk about your moms, really in a good way, I promise. But if you have questions about this topic, just jump right in. So the first thing I wanted to outline, and there's really 5 things that I think are interesting, at least as a first pass, when talking about some of the ways that our moms influence us. And I've known this for a while because, I mean, I've known this as an academic, and I've taught these kind of, some of these topics before. But as a practical clinician who works with data, functional neuroscientist, I see a lot of brains. 25 years, more than 10,000 people's brains I've seen over multiple assessments. And you start to see patterns that are really common across people. You get a sense of the phenotypes, the big patterns that tend to show up in people. But you also can see familial patterns that are the same, for instance, in siblings or in parents and kids. I've mapped several sets of identical twins. And a lot of the time, I would say about 80% of the time, maybe 3/4, the brain looks identical, which is really, really strange in a QEEG context. And then the last quarter of the time, the identical twins look just like any other siblings, where there's some similarity. But in terms of parents and kids, it's been known for a while in some ways that boys have their mama's brains. And you see this in a QEEG. You see that a lot of the big features that we can see around anxiety and sensory processing and social processing, the speed of processing, some of the executive function, these things are driven by, to some extent, the tuning of the cortex is driven by the powerfulness and the density of mitochondria. And all of the mitochondria that you get are from your mother, all of them. You don't get any mitochondria at all from your papa, all from your mama. So if your mama's kind of anxious and brilliant, well, guess what? That's where you got it. So you can thank her for that. So the density of mitochondria will really turn up the intensity of certain tissues involved with different features of the brain. And so for men, for boys, they only get one X chromosome, right? Generally. And so that means that you have one copy of the X, which is really matrilineal, right? From your mother, from her mother, etc., right? But if you're a girl, you still only have one active X chromosome, but you inherit 2. Every cell is going to have 2 X chromosomes from both sides, if you will, of your mother's side. So you end up with this pattern in women. So the first topic was mitochondrial inheritance, all your mitochondria from your mom. But as we think about girls versus boys, we can think about something called mosaic inheritance. So girls will have 2 copies of an X chromosome in every cell, but not every X chromosome is active. For the most part, one of those 2 copies will be randomly chosen and silenced in early development. So only one of them is really responsible for most of the growth and development and the things that the X chromosome does. So, boys have a specific tuning of their brain that's much more similar to mom's, and girls have a tuning of the brain because of the X that's sort of similar to the mom's side of the family, not just mom herself. So girls might look a little more like the aunt or the grandmother, perhaps, and not look as much like the mom in terms of behavior or some of these, brainwave patterns. They might still look a lot like mom, don't get me wrong. So you have this, again, mitochondrial inheritance for both boys and girls, only from matrilineal side. And then you have the X and Y chromosome thing. Now that's not the mitochondrial DNA, that's the other DNA, the regular DNA. And for those, girls get 2 X copies and boys get an XY typically. There are other variants that do happen, not a large percentage, but it does happen that there are other versions. And so we have this genetic composition, and this explains why the boys end up with a more similar brain to mom, and girls have a bit more of a diversity, a bit more of an assortment of traits that can be sort of resorted. The genetic variability is there probably to provide more resilience in the population and in the individual. So this is why we have these features. And then one thing to think about is, I guess a third topic out of the 5 is, what is the significance of the X chromosome that we only get from our moms? Is it, do boys have any real impact from the X chromosome? Yeah, we do actually. The X chromosome is heavily involved with brain development and development in general. So even though we're not using it to pass on. We aren't passing on the X chromosome as boys and men. We're using it in our development, and it is not a silent chromosome. So, this means we only have that one copy, and so its influence, genetically from our moms is outsized. Let me see, other notes I had on that. Basically, it means women have more, as I was saying earlier, more diversity, but also more of a balanced set of X-linked traits, and men's is more specifically about the mom's version. And these genes affect brain density, language development, even social awareness. So, you can thank your mom if you're a guy or boy. You can thank your mom's side of the family if you're a woman for these mitochondrial influences and X chromosome influences. So now another interesting feature, I want to get away from the direct impacts that individual children might be receiving for a second and think about some of the impacts of having these two X chromosomes. So I mentioned a genetic mosaicism, or a mosaic effect, where you get different X chromosomes silenced or activated randomly of the two if you're female. However, that doesn't seem to be perfect. There seems to be an ability of the cell or the chromosome to escape this silencing phenomena. And it seems to escape it. There's some types of genes within the X that might escape it really early in life, but then later in life, there seems to be this progressive escaping of some of the genes that might be involved with the brain. And so what that means is this could be one of the mechanisms. Having two X chromosomes, the second one might not remain deactivated throughout later life, and coming online, we might have this protective effect in aging. This may be one of the reasons that women tend to get the diseases of brain aging later than men. So, if you are a female, if you're a woman with X chromosomes, and I've got a couple of them, these things will potentially confer neuroprotective benefit later in life because of the reactivating, the escape of the silenced one back into an active state. Interesting stuff. And then the last thing that I really want to talk about a little bit is sort of epigenetics, which is the process of the environment modifying which genes are activated. And this is something, that the genes are doing all the time. They're creating different versions of activity or silencing based on often environmental triggers, or a lot of factors can silence or turn on genes, dietary factors, stress, all kinds of things. And it seems that this phenomena, this epigenetic activation and deactivation by the environment of gene expression, seems to be a phenomena that can sort of imprint on the genetic material and be carried on throughout generations. So there's good research showing that the way your brain uses cortisol will actually be carried intergenerationally. And this is not about the shared environment. This is not because your mom had a stressful house and therefore you grew up in a stressful house and experienced stress. It's actually a change genetically that gets triggered. So, classic genetics when I was in 5th grade, where you can't, pass on acquired traits. It seems that epigenetics may be the sort of exception to that, which is not a very small exception. And we're seeing, there's been research for years showing that people that experienced, concentration camps, for instance, in World War II, have a different expression of cortisol and reaction of cortisol. So do their children, and so do their children. So there seems to be this following on of stress responses. And by the same token, a mom that is, extra happy or extra stressed during development, during your development, will create an intrauterine environment that is more plasticity promoting, more growth promoting, or has more stress in it. So there seems to be a direct developmental, gestational, if you will, impact of the mom's active stress, but also an epigenetic, so genetic signature that's applied on top of the base code from the stress our mothers and our grandmothers experience especially. So be nice to your moms, be nice to your grandmothers. I know you always are, but if you haven't been recently, this is your reminder to be nice to your moms, because your mom gave you your mitochondria, and the mitochondria give you your unique characteristics of empathy and speed of processing and intelligence and awareness. Your dad had something to do with it, but the way those tissues are tuned has a lot to do with how fast they can rev and how hot they can run. You know, all the time I'm looking at QEEGs and I'm seeing blobs of beta waves being stuck, and it's the thing that the person cares about. You know, the overactive front midline can produce obsessiveness, or a brain that runs super fast is brilliant but kind of anxious. You know, so you'll see these phenomena in your moms and you. So on that note, if you're already a peak brain client and you're watching this video, I wanted to plug a special we're having where you don't have to do it in the month of April, but you have to sign up in the month of May. So we're running a Mother's Day special at Peak Brain where your mom can get a free brain map. And if you're already a Peak Brain client, just send your mom in. Just call us up. We'll call her, whatever you like, and we'll get her a free brain map. And if you're not a Peak Brain client, we're going to make the membership half price. So you can get a $250 membership instead of a $500, and then your mom can get a free one. And what that membership gets you is, within reason, an annual access to unlimited brain mapping in our Peak Brain offices, the ones in the US. So that's New York City, Los Angeles, Orange County, and St. Louis become your place to come and get brain map data and learn about how your brain works and watch how it changes over the months and years, do things to change it. And you really have this open-ended access to remap. And so we're offering that to our client base, or any recent client in the past year. And if you're older than that, your membership is more than a year old, or if you haven't signed up at Peak Brain, head on over. The link should be in the description, and we'll get you set up and can look at your brain with you as well. I know we have a lot of biohackers that watch these videos both live and later. So if you need any data, we are here for you. Radar is asking, my mom had to turn down the radio in the car to focus when she pulls the car out of a parking spot. Yeah, so some sensory integration stuff, and she's noticing the audio is distracting her visual attention. Interesting. So your mom's smart. It's probably a good accommodation. But if you did a brain map on your mom, you would probably see that the auditory tissues or the sensory tissues behind the ears would be running maybe low alpha power, so they're a little bit hard to filter the background world, or maybe large amount of theta power, same kind of thing, where the tissue is a little bit disinhibited. And Radar, I would bet if that's true, then your mom also has phenomena like she's a little bit irritated by people chewing too loud, and little random things like that might show up as well. It's a sensory integration thing, and sometimes you'll see those cluster together. So my session's coming up on the end, 18 minutes almost. The timer's behind my head. I'll just trust me on the 18 minutes. And if you have any questions, let me know, because those are my 5 topics. I think that I'll do a short video. It'll come out, the next week or two, which means a year before the next Mother's Day. But if you want to know more about these particular topics, please ask or leave questions in the video below, and I'll expand in the short form, more produced YouTube video in the next couple of weeks. Radar is saying, your mom has a really strong sense of smell. I think that's more common with women. It is. Women have more interconnectedness between the hemispheres. The corpus callosum is thicker. And I don't know if it's been firmly established, but there's some idea that the olfactory areas in the anterior commissure might also be thicker and more connected. So there seems to be a sort of faster, more connected brain in women in general, and women will often have a higher sense of smell. It can happen in men, but it's usually it's often more true in women. Hi, Kasim. Nice to see you. Thank you for choosing the topic. You're welcome. Happy to. Did you want to learn more about your mom? Always happy to, or someone's mom. Always happy to unpack things. Radar's asking, do other forms of biofeedback give permanent results like neurofeedback? My experience with HRV breath training seemed like the benefits went away when you stopped training. Yeah. So peripheral biofeedback, defined as biofeedback on the peripheral nervous system, as opposed to the central nervous system. So neurofeedback is central nervous system, and regular biofeedback is peripheral. And the difference between them is essentially if it's outside the bony structures, outside the skull and the spine, then it's peripheral. And you're aware of the peripheral nervous system. You can feel it. You cannot feel your brain. You cannot feel your brain tissue. There's no sensory nerve endings in there. And so what that means is the process of neurofeedback is essentially involuntary shaping. It's this process where the brain is exercised and you get an effect. You feel neurofeedback after you do it or while you're doing it, but you're not trying to do it. In peripheral biofeedback, you're measuring some signal like the heart rate or the breathing or galvanic skin response, resistance, conductance, or a few other things that you can measure. And you're sort of watching a continuous signal often, and you can get a sense of how that signal is changing by kind of feeling the body. So in the case of HRV, you kind of pace your breathing in a certain way, and at some point you kind of drop into the zone. You have a parasympathetic response instead of a sympathetic activation, more of a rest and repair, and you end up with this softening of the activation tone. And you can feel that happening. And as you feel that happening, the biofeedback gives you a ping and you're like, oh yeah, that's what that feels like. And so you're starting to get a little hint of where that skill is, so that parasympathetic ability to downshift when you want to pull back from the precipice of strong activation. And this phenomena is something we do all the time. We manage that sympathetic parasympathetic balance. So if you practice hanging out at that change moment and getting cues, auditory, visual cues about when it's happening, it doesn't push the brain or the body in that direction, but what it does is it teaches the mind how to control the brain or body in that direction. So it's more of a voluntary skill. You're learning to kind of reach for the lever of parasympathetic, downshifting and do it more voluntarily. It teaches you where that skill is, and then you practice that until there's something called skill transfer, when you can reach for that not sitting hooked up to the machine. You're in a checkout line, the supermarket, or you're driving, somebody cuts you off and stress happens. Well, you recognize that, you reach for the ability to downregulate, downshift, and you're going to unclench that activation tone and pull back because you know what it feels like. You know where the lever, the handle, the door, the button is to turn that resource on. Now, the question was, does that last? Because it didn't feel like it did for radar. And yeah, the thing about peripheral nervous system training is initially, certainly it wears off when you stop doing it. If you keep doing it, the skill transfer does get more stable. But HRV especially is one of those things where you might build up a lot of stable, improved heart rate variability, increased tone of that system. And if you practice that enough, you'll remain, with some better regulatory skills. But you probably should buy the device and put it in a drawer when you're done, because in a year or 2 or 3, or the next time your life falls over a little bit, or you go on night shift, you stop eating well, your control over that vagal tone, that HRV is the vagus nerve, your control over that may erode, and your voluntary control may be hard to establish. And so you pull the device back out, you train up a little more, you reestablish the skill, and now you can go about doing it more voluntarily. So that's how you go after biofeedback, peripheral biofeedback. Now, because you're training the vagus nerve and the HRV, you also actually end up with the cingulates being trained through the HRV. And so if you train the HRV with breathing and HRV biofeedback and train the cingulates with EEG neurofeedback, you're very likely to get a more permanent shift in the HRV as well. So, you're a whole system. You're not just your heart. You're not just your brain waves. So you can always think about training these systems together because they are a little bit interconnected in many of these ways. Kasim, you're more than welcome. Thank you for showing up and participating. Really enjoy it. Radar's asking, is it possible to do neurofeedback on the spine? I believe there are people who do it in terms of it's been done experimentally, I know, at least, where people have tried to do it to see if they can bridge spinal injuries or trigger healing. I don't know what the success rate is. I do know there are some experimental, I think it's actually starting to get outside of the lab into semi-commercial production of devices that are biofeedback, but not exactly in the way you're thinking. Not biofeedback training that's adaptive and trying to push the spine. Instead, there's biofeedback devices that'll try to bridge a spinal break, and we'll try to send signals out into the body in response to what the brain is doing. And that will then create a feedback loop. So it's biofeedback still. The body would then have to learn to use those signals to then feedback and get control. I don't think it's perfectly usable yet. There have been several experiments done, though, where you can measure the the walking areas of the brain in real time. They've done this on monkeys a few times, on chimps, where there's a monkey in Japan walking in a treadmill with wires on its head, and there's a robot in New York City whose legs are being controlled by the monkey walking. And initially they walk together, but eventually the monkey can be immobilized and not moving its legs and still be walking the robot in New York City based on seeing the scene change around the sort of video that's around the cameras kept the same. So yeah, you have monkeys remotely controlling robotic legs in, across the ocean. And that's a biofeedback event. The monkey learned to use the legs by first having it mimic the brain activity that its own legs were doing. And then after its legs were immobilized, the brain took over, moving the legs it was seeing move itself through a virtual environment. It's a biofeedback kind of thing. But that's neurofeedback, really. That's not really on the spine. That's on the motor area of the brain. So I'm assuming that we'll have something sooner or later, like a cochlear implant, but for spinal breaks or damage, or we'll have some ability for stem cell regeneration at some point. But the spine's a very tough set of tissue to have compromised, and it tends to cause a lot of difficulty that we haven't really got a lot of good treatments to work on at this stage. I would say that, more often than not, we're doing biofeedback around things the spine is causing, like pain. If you have a lot of spinal damage or breaks or rods or, a bunch of stuff, scoliosis, you'll have a lot of really wonky pain. And, neurofeedback, of course, can work on that. But again, you're more working on the brain part of the central nervous system, not the spine part. Great question, though. I really appreciate that. So, guys, thanks so much for hanging out with me tonight. If you have any more questions, lay them on me before we stop. I'll probably give it a few more seconds and then be done for the night. And let me know other topics you might want me to check out over the next few weeks. I have, I think, missed a couple of them in the past year, 2 or 3 total. But we're coming up on a year of doing these live streams in July. And so I'll get you guys through that year. I might change formats by that point into doing maybe 1 live stream a month for an hour covering news topics, and then really hang out more towards doing more produced videos, because I can do those more in a more time efficient way, unless you really like these live streams. So please let me know if you want. I promise you not to go down in volume, but I don't care. I don't know if you care if this is live or not. So I am going to do a bunch of shorter 10-minute videos on some of these topics and try to just distill down, not just what I told you in the first videos, but other things that have come out of people asking questions about them or talking to me about the content, or other things that I've learned or thought about since. So I'll start distilling these things down as we hit midsummer. I might pull back into a less than weekly format for the lives, unless you really want them, and then I'll keep doing them. So, let me know what you want. All right, guys, well, have a lovely evening and take care of those brains if it's evening for you, or morning if it's morning for you, wherever you happen to be. And I hope to see you on the next live stream. Let me know if there's specific topics. Do me a favor, like the video, subscribe to the channel, and leave a comment or two. Find a video, like it, subscribe it, share it. Engagement with videos, especially of that flavor, tends to really capture the YouTube algorithm's attention. So if you have a moment or two, go ahead and spread some thumbs up. And otherwise, I will see you in a week, next Monday, and take